Hello everyone, I am Chaitanya. Today we are going to discuss about the laws of logic, logical implication. Introduction to the laws of logic and logical implications. The laws of logic are fundamental principles that govern reasoning and argumentation. Logical implications is the relationship between statements where one statement necessarily follows from another. Understanding these concepts is essential for critical thinking and problem solving. Law of identity. The law of identity states that a proposition is identical to itself. In symbolical logic, this law is represented as P is equals to P. It is a foundation principle in logic that helps establish the truth of statements. Law of non-contradiction. The law of non-contradiction asserts that contradictory statements cannot both be true at the same time. In symbolic logic, this law is represented as negation of P and negation of P. This law is essential for maintaining logical consistency in reasoning. Law of excluded middle. The law of excluded middle states that the statement is either true or false with no middle group. In symbolic logic, this law is represented as P or negation of P. This principle is crucial for making clear and definite conclusions. Modus ponens. Modus ponens is a valid form of argument that establishes a conditional statement. It follows a pattern that if P then Q, P therefore Q. This rule of inference is essential for drawing logical conclusions from premises. Modus tollness. Modus tollness is another valid form of argument that denies the consequent of a conditional statement. It follows that pattern if P then Q, not Q, therefore not P. This rule of inference is useful for negating implications and drawing logical inferences. Hypothetical syllogism. Hypothetical syllogism is a logical rule that allows for chaining of unconditional statements. It allows the pattern if P then Q, if Q then R, therefore if P then R. This rule is essential for constructing complex arguments based on conditional relationships. Disjunctive syllogism. Disjunctive syllogism is a valid form of argument that eliminates one of the disjuncts in the logical disjunction. It follows the pattern P or Q, not P, therefore Q. This rule of inference is useful for deriving conclusions from disjunctive statements. Constructive dilemma. Constructive dilemma is a logical rule that combines two conditional statements in a disjunctive form. It follows the pattern if P then Q, if R then S, therefore Q or S. This rule is effective for presenting choices and consequences in arguments. Simplification. Simplification is a logical rule that reduces a conjunction to one of its conjuncts. It follows the pattern P and Q, therefore P. This rule is useful for breaking down complex statements into simpler components. Conjunction. Conjunction is a logical rule that combines two statements into a single conjunction. It follows the pattern P, Q, therefore P and Q. This rule is essential for building compound statements from individual components. Addition. Addition is a logical rule that introduces a new statement based on an existing one. It follows the pattern P, therefore P or Q. This rule is useful for expanding arguments and introducing new possibilities. Absorption. Absorption is a logical rule that simplifies a compound statement by absorbing one of its components. It follows the pattern P and of P or Q, therefore P. This rule is helpful for reducing redundancy in logical expressions. De Morgan's law. De Morgan's law are a set of rules that describes the negation of logical conjunction and disjunction. They state that negation of P and Q is equivalent to negation of P or negation of Q, and negation of P or Q is equivalent to negation of P and negation of Q. These laws are crucial for manipulating logical expressions and simplifying complex statements. Contraposition. Contraposition is a logical rule that transforms a conditional statement by negating both the attendance and consequent. It follows the pattern if P then Q. Therefore, if negation of Q then negation of P. This rule is useful for exploring the contrapositive of an implication. Biconditional introduction. Biconditional introduction establishes a biconditional statement by showing the mutual implications of two conditions. It follows the pattern. If P then Q, if Q then P, therefore P then Q. This rule is essential for expressing equivalence between two statements. Biconditional elimination. Biconditional elimination derives two conditional statements from a biconditional statement. It follows the pattern P equivalent to Q. Therefore, if P then Q and if Q then P. This rule is useful for breaking down equivalence relationships into simpler implications. Indirect proof. Indirect proof is a method of proving a statement by assuming its negation and deriving a contradiction. It follows the pattern. Assume negation of P, derive a contradiction, therefore P. This proof technique is powerful for establishing the truth of a statement indirectly. Validity versus soundness. Validity refers to the logical structure of an argument where the conclusion follows logically from the premises. Soundness goes beyond validity and ensures that the premises are actually true, leading to the valid and true conclusion. Understanding the difference between validity and soundness is crucial for evaluating arguments. Conclusion and summary. The law of logic and logical implications provide a foundation for sound reasoning and arguments. By applying these principles, we can construct valid arguments, draw logical inferences, and evaluate the validity of statements. Mastering these concepts is essential for critical thinking, problem solving, and effective communication. Thank you.